Okay, there's one more part to part B. Find cube root 1728 by prime factorization. Common mistake. Again, students maybe they are stressed during exam, they will just put into calculator and get the answer. 0 marks. Okay, 0 marks. Because it says very clearly here, find it by using prime factorization. Alright, which means that you have to go and prime factorize the 1728 first. Okay, how do I do that? You can put it into a ladder also as well. Okay, divide by 2, A64, divide by 2 again, 432, divide by 2 again, 216, and you can carry that on, divide by another 2, 108, there are quite a few 2s over here, 54, divide by 2 again, 27, and now we go on to the 3s, 3, 3, 3. Okay, so I know that 1728 can now be expressed as, how many 2s do I have? 1, 2, 3, 4, 5, 6 2s times 3 cubed. That is the prime factorization of 1728, right? When I apply a cube root to it, I can say that the cube root of 1728 is the same as the cube root of its prime factorization. Because I already simplified what is 1728 already. It is 2 to the power 6 times 3 to the power 3. What does a cube root do to your powers? It divides your powers. What are powers, by the way? Powers are these two things here. Whenever you cube root something, the powers will be divided by 3. Okay, because cube root, there's a 3 over here also, right? So end up, you will have 2 to the power of 2 times 3 to the power of 1. Because 6 divided by 3 is 2, 3 divided by 3 is 1. To make it clearer to you, maybe I'll do it this way instead. Whenever you cube root something, oh sorry, not multiply. Whenever you cube root something, this is what's going to happen. Okay, this is what's going to happen. Then from there, you have 2 squared times 3, 1. But 3 to the power of 1, right, is just 3. You can check your calculator. 3 to the power 1 is just 3, so you can just remove it. It doesn't affect our answer. And this will be equals to 4 times 3, and the final answer is 12. Okay? So just to recap with you, cube root, you divide the power by 3. Square root, right, you will divide the power by 2. Okay, by 2. Let me just show you a quick example on top here. Copy down the quick example. I'll do it in green also. So if I have square root of 2 squared times 5 to the power of 4, right? This is a square root, right? Square root. For square root, what's going to happen is that I can divide the powers by 2. And I'll get, which is simply just, okay? So for square root, divide the power by 2. For cube root, divide the power by 3. Must remember this. All right, it is quite important. Okay, let me zoom out a bit, then we can move on. Ashley's purse contained X 10-cent coins and X plus 5 20-cent coins. Now, normally for this kind of question, my advice to students is that write down in your own words what this means first. The thing about problem sum is that there are a lot of words, a lot of information. Imagine if I make the question even harder. I say X 10-cent coins, X plus 5 20-cent coins, twice the number of $1 coins. It can be very confusing. So what I will do is that I will ask my students to write this down first. Okay, 10-cent coins, number of 10-cent coins, how many do I have? Number of 10-cent coins, X. Number of 20-cent coins, X plus 5. This will help you to be less stressed during exams because you can see more clearly what the question is talking about. They want the total amount of money, right? Okay, in what? Please read, don't just jump to the question. Total amount of money in dollars. Okay, dollars. Meaning, right, the student does this, 10 cents times X, right? Plus 20 cents times X plus 5. It will be wrong already. It will be wrong already because they want it to be dollars. So 10 cents is how many of a dollar? In decimal form? Okay, we know that 10 cents is actually $0.10, right? And 20 cents, we know that is, okay? So to use it to your advantage, you can write it out very clearly. The total amount of money, okay, total amount is equals to 10 cents multiplied by X, right? Plus 20 cents or $0.2 multiplied by X plus 5. Now, as you move on in Sec 2, Sec 3, right, you realize that it is faster and cleaner. I use the word cleaner to put multiplications as brackets, which means that I'll put it this way instead. Okay, I'll put it this way instead. Then from there, you can apply your multiplication. This will just be 0.1x. Okay, rainbow here, rainbow here. Can use calculator. 0.2 times x will just be 0.2x. 0.2 times 5 will be 1. So to simplify it a bit, the final answer will be 0.3x plus $1. Okay, this should be the expression for total amount of money in Ashley's purse. Okay, remember that you need to put a bracket. Yeah, actually, if you want to play safe, I just put bracket for everything. Okay, because the dollar sign should be on the outside. It belongs to both terms. Okay, all the coins add up to a total of $4.30. Form an equation and solve it to find the total number of coins in her purse. Now, I want to caution you a bit. If they say form an equation, right, please, you can say goodbye to your model, to your logic method or whatever. It must have equation and algebra inside your answer already the moment they say this. When they say this also, form in terms of x, you cannot use model, you cannot use other methods or units or whatever. You have to use algebra, no choice. Okay. So form an equation, that means there will be equal sign somewhere, right? Something will be equal to something. That's the meaning of equation. There's an equal sign somewhere. In this case, in part A, you already found the total amount of money, right? Total amount of money in the purse, which is 0.3x plus 1. And the question has told you that the total amount of money is $4.30, which means that here will be $4.30. Make sense to you? Okay? Because over here, both are total amount, right? One in algebra, one in numbers. Okay, remove the dollar sign. It's very confusing. So just put it this way. It will be easier for you. Shift over a number, you will get 0.3x equal 4.3 minus 1, right? Because I moved it over. I shifted the plus 1 over to the right side of my equation to get minus 1. And the last step, last two steps, sorry, you will get equal to 3.3. X will be equals to 11. Okay, 3.3 divided by 0.3 is 11. But wait, are we done yet? No, right? What is X actually? Always ask yourself, what did the question say, or what do you allow X to become? X is not the final answer, right? They want the total number of coins in the purse. X is just the number of 10-cent coins. We still need to add the number of 20-cent coins. So now we can write it this way. Number of 10-cent coins is 11. So the number of 20-cent coins is going to be 11 plus 5, which is 16. So final answer, add together, you should get 27 coins in the purse. Now, where did I get the plus 5 from? From here. X plus 5, right? That's why here is 11 plus 5, because X is 11. Okay? All right, let me zoom out so you can copy down what you need for this speech before we carry on. All right? Okay, 1 minute, copy down what you need.